Hello everyone. This in this video we will going to learn about the measurement of discharge of a canal. Okay. Now this is the last point of module canal. Okay, this is the last point of module canal headworks and the distribution system, where we have studied the waterlogging, effects of waterlogging, canal classification, canal alignment, canal losses, lining of canal and maintenance of canals. Okay, maintenance of service roads also. So this part is the last part of the module, measurement of discharge of a canal. Now in this the different methods for calculating the discharge or measuring the discharge through particular canal section are mentioned and described. Now, it is necessary to know the discharge flowing in a canal section so that we can efficiently or effectively do the irrigation work for particular catchment area. Now, uh, the measurement of discharge may give an idea of the amount of silting and the canal losses. These are the principal methods for calculating or measuring a discharge. There are five methods for it. First is area velocity method, then chemical method, then wear method, then meter flume method, then stage discharge curve method. Now we'll see one by one what is area velocity, what is chemical method, and what is wear method, meter flume and stage discharge curve method. Now first is area velocity method. Now in fluid mechanics or applied hydraulics, you have studied that discharge by using continuity equation, we can calculate the discharge as Q equals to area into velocity. Okay, डिस्चार्ज क्या होता है कंटिन्यूटी इक्वेशन के हिसाब से Q equals to A into V. Okay, that means we can say that A1 V1 will be equals to A2 V2 also. Okay, so here discharge, by this method discharge is calculating using area into velocity. Okay, but this is more general method and this is applicable for river and canal also. Okay, this method can be applicable for river also and for canal also. And this method consists of a measuring area of a channel, particular channel section, and also the measurement of mean velocity of flow through the channel. Hmm. Firstly, we have to calculate the area and then we have to calculate the mean velocity of particular channel. Hmm. Now, area मिलेगा, velocity मिलेगी, तो by calculating or by multiplying both area and velocity, we can obtain the discharge through that channel section. Now, the measurement of velocity part. Here, the main problem for measuring discharge in a particular through a particular channel is the accurate determination of velocity. Okay, main problem for measuring discharge is the accurate determination of velocity. Now the velocity distribution, here the diagram shows the velocity distribution in a open channel. Here in this you can see the contours of equal velocity. Here they have showed the contours of equal velocity, the depth of particular channel section, and here the velocity profile of an vertical section is shown. Now, for measuring the velocity in the channel section, a straight and well defined reach of channel section should be selected. Okay, because we have to calculate the velocity, so well defined reach and a straight reach should be selected so that we can easily calculate or easily measure the velocity of that channel section. Now the side should be also free from the disturbing influences. Okay, like hydraulic structures, मतलब जो भी disturbing influences है, जो भी हम लोग साइट सिलेक्ट करने वाले हैं, दैट साइट शुड बी फ्री फ्रॉम द डिस्टर्बिंग इन्फ्लुएंसेस. ओके, अदरवाइज क्या होगा कि वेलोसिटी वैरी हो जाएगी. डिस्टर्बिंग, कोई भी डिस्टर्बेंस अगर उस पाथ में आया तो वेलोसिटी आइदर डिक्रीज्ड मिलेगी या फिर इंक्रीज्ड मिलेगी. ओके, सो वी हैव टू सिलेक्ट अ साइट such that that site should be free from such influences, such disturbances. So and also the structure, that hydraulic structure, uh, अगर अगर कोई हाइड्रोलिक स्ट्रक्चर आया, देन दैट स्ट्रक्चर विल बी अफेक्टेड बाय बैक वाटर कर्व. Okay, backwater curve. So we have to select the site such that it is free from disturbing influences. Now the cross sectional area of that site which we are going to select, that also fairly constant. Okay, that also should be fairly constant. Now the velocity in the channel section can be found out by different methods. There is not only one method for calculating velocity or measuring velocity, but there are six methods to find out the velocity in particular channel section. So we'll see one by one. There are six methods. First is surface float, then subsurface float, then twin float, then velocity rod or floats, then current meter method, then pitot tube method. Okay, the pitot tube, you have already heard about it. Okay, I'll explain one by one. First is surface float method. Now here, the surface floats are made up of light material such as cork or a hollow wooden blocks. Okay, wooden blocks के क्यों होते हैं? So that they can easily float on the surface. Okay, they are painted on the top and sometimes they are attached with the flags so that they can easily distinguished from one another. Hmm? Two wire ropes here in this method particular, two wire ropes are stretched across the channel section. At one is at the beginning and other is at the end of the selected reach. Okay, दो वायर्स रोप होते हैं. एक जो वायर रोप है that is stretched at the beginning and another is stretched at the end of the selected reach. Okay, now the distance between these two is called as a test reach. Okay, this in between these two wire ropes, the distance is called as test reach. Now the third rope is introduced. This third rope is stretched upstream of the test reach by 15 to 20 meters. Okay, this third rope is stretched upstream of test reach by 15 to 20 meters. Now all these three ropes are marked at various points. Hmm. जो भी तीन ropes है, that three ropes are marked at various points so that we can easily divide the channel width. Okay, so that we can easily divide the channel width. I'll show the diagram of similar diagram. This similar diagram. Oh, sorry. Here you can see this is divided into number of points. Okay, this is one part, this is the second, this is your track of float. Okay, track of float. In similar way the surface float method is worked. Okay, now from that points the floats are dropped in the water along the various paths. Okay, now जो भी फ्लोट हम लोग ड्रॉप करेंगे दैट फ्लोट विल acquire uniform velocity. Okay, by the time they enter the test reach. The time of travel of the test reach of only those floats which follow their correct path is recorded. जो भी करेक्ट पाथ फॉलो करेंगे फ्लोट, दैट the time travel by that float only we have to record. Okay, now the velocity, how to calculate the velocity? Velocity will calculate by distance traveled by that float divided by the time taken. Okay, distance traveled by that particular float divided by time taken will give you the velocity of that float. Hmm. Now, if the channel section is too large or sufficiently large, then the length of the test reach should be 50 meters to 75 meters. Okay, and if the line or a small channel is there, then this length should be 15 to 20 meters. ओके ना, अगर यहाँ पे आप देखिए तो ये हम लोग सरफेस पे ही फ्लोट करने वाले हैं। जो भी आपका फ्लोट है वो सरफेस पे ही फ्लोट करने वाला है। तो विंड विल अफेक्ट दैट फ्लोट्स। ओके, सो वी हैव टू take one point in mind that this method of observing velocity should be carried where the wind is not so strong. Okay, that means there is no strong breeze is there, we can use this method in the particular area. Okay, because wind will affect your calculations or measurement part. Now second is subsurface float. Here the diagram shows it is also the similar to that of surface float, but surface float gives only surface velocity. Okay, and it is usually required to find out the mean velocity of channel section. मतलब जो भी channel section है उस section में जो भी mean velocity है, that mean velocity we have to find out. Okay, so the subsurface float or double float are used for finding out it. Now here this subsurface float consists of hollow metal sphere, here hollow metal sphere, or a cylindrical rod, velocity rod, attached to the surface float. Here surface float को वो अटैच किया हुआ है by means of a cord. Okay, ये cord है and ये this is your surface float. By means of a cord, this subsurface float is attached to surface float. Hmm. Now the length of cord is adjustable so as to reduce or increase the distance or depth of float. Now mean velocity can be obtained by adjusting the length of cord such that the center of sphere is to 0.2 d above the bed level. ओके, मतलब जो डेप्थ है आपकी वाटर की डेप्थ है दैट 0.2 टाइम्स दैट डेप्थ वो फ्लोट है, जो सब सरफेस फ्लोट है वो ऊपर होना चाहिए. ओके, देन only we can calculate the mean velocity of the channel section. Now the twin float. Third is twin float. Twin float consists of two hollow metal spheres attached with cords. Here, two hollow metal spheres are attached with the cords. Upper sphere floats on the surface, and lower sphere is sphere. Okay, it is so weight that it can keep the float vertical. Okay, now mean velocity of it can be obtained if lower float is just clear of the bottom. ओके, यहाँ पे भी सेम कैलकुलेट करना है डिस्टेंस एंड टाइम से. लोअर स्फीयर जस्ट क्लियर ऑफ करेगा बॉटम से, तभी हम लोग ये वेलोसिटी कैलकुलेट कर सकते हैं. अभी वो टच भी नहीं होना चाहिए, वो सिंपली थोड़ी डिस्टेंस ऊपर होना चाहिए. नाउ द वेलोसिटी रॉड और रॉड फ्लोट्स. हियर द वेलोसिटी रॉड्स ऑफ आर मेड अप ऑफ hollow tube or wooden rods. They are usually made up of made telescopic. They are usually made telescopic with one tube sliding into another. Okay, here they can stand vertical, so their length is adjusted in such a way that the bottom of float may be clear of the bottom of the your river bed by few centimeters. Hmm. Now the mean velocity can be calculated by, here formula is shown. Mean velocity Vm equals to V in bracket 1.02 minus 0.116 root of d1 by d. Okay, here d1 is nothing but the clearance between lower end of rod and bed. D is your depth of channel. V is the observed velocity. Okay, V is the observed velocity. Now second is current meter method. Now current meter method is generally used method. It consists of a device which measures the velocity in channel directly. Okay, now here the instrument consists of, here diagram shows the current meter instrument. This instrument consists of a wheel which is caused to revolve by the force of current when it is immersed in water. Okay, and it is provided with the gear to record the number of revolutions, hmm, of that wheel. Now by using that revolution number we can calculate the mean velocity. Okay, now according to the revolving parts used for the current meter, it is classified into two types. Okay, first is conical cup type current meter, and second is a helicoidal vanes type current meter. Okay, but in these two types, the conical cup type current meter is largely used, so we can study this type of current meter. Okay, it is more popular. Now how to uh, how to find out the rating of current? The current meter, I'll explain the working. The current meter is placed in an artificial channel, okay, of a known velocity. Now the instrument is suspended in the channel of the suitable depth. Okay, ये एक channel है, उसकी velocity आपको पता है, known velocity है ना, उस पे वो इंस्ट्रूमेंट सस्पेंड किया है इन दी known depth also. Now the number of revolutions recorded by the meter corresponding to the velocities is determined. Number of revolutions we can determine. Now the graph is plotted with velocity per second as the ordinate and number of revolutions per second as abscissa. Okay. Now this is known as your rating curve. Okay, this is known as your rating curve. Velocity in the channel is directly proportional to the number of revolutions. Okay, so rating curve is a straight line. So rating curve is a straight line because the revolutions is your velocity of channel is directly proportional to the number of revolutions, so that the curve is a straight line. Okay, now this is about your laboratory. Okay, now how to use this in field? Now uh, on the channels of not too large depth, the instrument is usually mounted on the rod on which it can be fixed in any position. Now the rod is made to rest on the bed of channel. जो rod होगा वो bed पे rest करेगा. Okay, now whereas where the velocity is to be determined, जहाँ पे भी आपको velocity determine करनी है वहाँ पे bed पे वो rod आपका rest करेगा. uh, ये होगा स्मॉल डेप्थ के चैनल के लिए. whereas on the large channel the current meter is suspended from the boat by means of cable and is weighed down by a heavy streamlined anchor. ओके, यहाँ पे हम लोग डेप्थ ज्यादा है तो हम लोग रॉड नहीं यूज कर सकते. यहाँ पे दैट करंट मीटर इज सस्पेंडेड फ्रॉम द टॉप. Okay. Now current meter is used in following ways. लार्ज या फिर स्मॉल डेप्थ के लिए फॉलोइंग वेज में हम लोग ये यूज कर सकते हैं. फर्स्ट इज सिंगल पॉइंट मेथड, सेकेंड इज डबल पॉइंट मेथड, and third is integration method. Okay, very simple methods these are. First is single point. Now the current meter is immersed at 0.6 of the depth of stream. ओके, 0.6 डी डिस्टेंस पे वो करंट मीटर जो है, दैट करंट मीटर इज टू बी इमर्स्ड. ओके, नाउ एट दिस डेप्थ velocity recorded is the mean velocity. The channel section is divided into various compartments, and the velocity and center of each compartment is noted. Single point method is suitable for streams having large depth where the meter cannot suspended at 0.8 d. Okay, now this single point method gives the error of 5% to the mean velocity. ओके, यहाँ पे जो भी कंपार्टमेंट्स हम लोग डिवाइड करने वाले हैं, दैट कंपार्टमेंट्स के जो सेंटर्स होंगे वहाँ पे हम लोग वो करंट मीटर प्लेस करेंगे 0.6 टी पे, एंड मीन वेलोसिटी फाइंड आउट करेंगे. ठीक है, एक ही सिंगल पॉइंट पे. नाउ द डबल पॉइंट मेथड. In double point method, the meter is introduced at 0.2d and 0.6d of that stream. यहाँ पे दो पॉइंट्स पे सस्पेंड किया है और इमर्स्ड किया है. नाउ द एवरेज ऑफ दीज टू वेलोसिटीज गिव्स द मीन वेलोसिटी इन द सेक्शन. ओके, गिव्स द मीन वेलोसिटी इन सेक्शन. सिंगल पॉइंट पे क्या था कि हम लोग 0.6 डी पे जो भी वेलोसिटी निकालेंगे, दैट वेलोसिटी इज योर mean velocity. Now in double point method, we are going to introduce or immerse the current meter in two different depths. Okay, first is 0.2d and second is 0.6d. Now the average of these two is your mean velocity. ओके, नाउ द इंटीग्रेशन मेथड. इंटीग्रेशन मेथड में हम लोग जो भी करंट मीटर है, दैट करंट मीटर इज इंट्रोड्यूस्ड इन वेरियस स्टेप्स, इमर्स्ड इन वेरियस स्टेप्स सच एज 0.1d, 0.2d, 0.3d, 0.4d. Okay, now the velocities recorded at these depths are then averaged and find out the mean velocity. इंटीग्रेशन पे वेरियस डेप्थ्स पे इंट्रोड्यूस करेंगे. डबल पॉइंट पे 2, सिंगल पॉइंट पे 1. ओके, नाउ द इंटीग्रेशन मेथड इज मोर एक्यूरेट देन सिंगल पॉइंट एंड डबल पॉइंट मेथड बिकॉज वी आर गोइंग टू टेक various depths and various velocities, and then we are going to average that. Okay, now last is second last is a pitot tube. Now this pitot tube method is suitable for laboratories because in field the entrance of tube may get clogged by the fine silt, so this method is used for laboratory only. The pitot tube is suspended in the stream with its nozzle pointing upstream. Due to the dynamic pressure which is exerted on the mouth of the tube by flowing water, the level of water in the vertical limb of tube rises above the water surface of channel. Okay, now that amount will be h. Now velocity in the channel can be calculated by using root of 2gh. H is nothing but the rise of water surface of the channel. Okay, that h is rise of water surface of the channel. Now the last is measurement of area of flow. अभी ये जो मेथड्स हम लोग ने देखे, दिस मेथड्स आर फॉर फाइंडिंग आउट द velocity of water in a particular channel. Now the measurement of area. In this diagram, you can see that the cross sectional area is divided into number of small vertical strips. Okay. Now, for measuring the width of strips, a steel cable is suspended from two towers From the cable, the ropes are hung and chained to touch the surface of water at the regular interval. Now, the depth of water at each point is measured by sounding pole. Sounding pole you have already studied. Sounding by means of sounding pole, the depth at each section is calculated. Okay. Uh, Now the velocity, if we have find out the velocity at particular sections. Suppose here d1 is there. Okay, then we are going to calculate the area. d1 की जगह पे area होगा a1, and when we are going to calculate the velocity at this section v1, velocity at this section v2, v3, v4, v5, v6. ओके, तो एरिया भी है 6 सेक्शंस के, वेलोसिटीज भी है 6 सेक्शंस की, तो डिस्चार्ज हम लोग फाइंड आउट कर सकते हैं एज q1 q इक्वल्स टू a1 v1 प्लस a2 v2 plus and so on a6 v6. Okay, this is about the area velocity method of finding out the discharge of canal. Now second is chemical method. अभी यहाँ पे क्या करते हैं कि एक सॉल्यूशन जिसकी स्ट्रेंथ आपको पता है एंड वेट पता है, ओके, दैट इज इंजेक्टेड यूनिफॉर्मली ओवर द क्रॉस सेक्शन. जनरली द सॉल्यूशन इज ऑफ सॉल्ट सॉल्यूशन. ना ये जो है वो यूनिफॉर्मली हम लोग इंजेक्ट करेंगे किसी भी क्रॉस सेक्शन पे, जो क्रॉस सेक्शन आप लोग चूज करेंगे. नाउ after injection that is allowed to mix, okay, allowed to thoroughly mix to the water. then मिक्स होने के बाद क्या करेगा कि वो जो वाटर होगा वो ट्रेवल करेगा टू द डाउन स्ट्रीम. ओके, नाउ फ्रॉम somewhere in the downstream the sample is collected. Okay, from somewhere in the downstream we can collect the sample of that mixed solution. Now the concentration of salt in that sample is determined by using the titration method. Okay, now the titration should be done with the silver nitrate and potassium chromate. Hmm? Now since the water may contain the salt originally, अभी हम लोग ने इंड्यूस्ड किया है उस पे, लेकिन दैट वाटर इन कैनाल may have some salt originally. So the concentration of salt in undosed water is also determined. Now by knowing the concentration of salt in the sample, the volume of water Q flowing per second can be obtained. Okay, the formula for that is Q equals to W1 minus W naught divided by W2 minus W naught into Q, where W1 is जो हम लोग ने सॉल्ट का वेट इंजेक्ट किया है वाटर में, दैट सॉल्ट सॉल्यूशन का वेट. W नॉट इज अनडोस्ड वाटर में जो भी सॉल्ट होगा दैट वेट, एंड W2 इज वेट ऑफ सॉल्ट of dosed water, okay, obtained from that sample. Q is the amount of solution injected. Now this is the chemical method where we are going to inject externally the salt solution in particular water, and by using the titration method, that is chemical method, we are going to calculate the volume of water flowing per second. Now, third is weir method. This is also a very simple method. Weirs and notches you have already studied in fluid mechanics. Here, the water is allowed to flow over a broad crested or a sharp crested weir, and the head over that weir is measured for finding out the discharge. Now here the rectangular or a triangular notch can also be fitted, and for both the weirs and notches you have already learned the formulas for finding out the discharge over the weirs and notches. So here the equations for each that is broad crusted or wear, sharp crusted wear, and equation for V notch is shown. Okay, these are the discharge equations for wear method. Next is meter flume. This method is similar to that of venturimeter. Venturimeter you have studied, the throat section is there, and one is upstream side and the second is your downstream side normal section also. So discharge measurement by using meter flume is similar to that of by using venturimeters. Okay, the channel width is restricted uh, from the throat with smooth entry and exit transitions on both sides. Okay, throat sections पे भी channel width जो है वो restrict होगी. Now here in this figure, the depth of water at throat and at the upstream normal section is recorded by means of two gauge wells is shown. Here gauge wells are there, two gauge chambers you have shown here. They have shown the gauge chambers, and this is the plan of that particular meter flume. So by using this meter flume, we can calculate the discharge by using the equation as C A1 A2 root of 2G in bracket H minus H divided by root of A1 square minus A2 square, where A1 A2 are the areas of normal section and throat section. H is also the depth of normal section and depth of throat section. Q is the discharge and C is your coefficient of flume. Yeah, this is about your meter flume. And this is the storage discharge curve, which is the last method for finding out the discharge of canal section. Now, stage discharge curve. By mistake, I have written is storage discharge. This is the stage discharge curve. Stage discharge curve is the curve between discharge and the depth of water in the channel section at particular stages. Now, this stage or depth is plotted as a ordinate here. Here you can see that stage in meters is plotted and in the y-axis, and discharge in cumex is plotted in the x-axis. Okay. Now, once this stage discharge curve or a depth discharge curve is plotted, it can be used for finding out the discharge at any subsequent period by measuring the stage. Okay, जब भी ये कर्व हम लोग प्लॉट करेंगे तो उसके हिसाब से किसी भी सब्सिक्वेंट पीरियड में हम लोग डेप्थ फाइंड आउट करके उसका डिस्चार्ज बता सकते हैं. ठीक है, नाउ दिस स्टेज डिस्चार्ज कर्व मस्ट बी चेक पीरियोडिकली as the regime conditions and of channel are evenly changes. Okay, that means periodically that regime conditions will change, so this curve should be checked periodically. Okay, now from this video we have covered the module canal headworks and distribution system. All this module is over. Up to this video we have covered all the points in it, like lining of canal, types of lining, waterlogging and all. So I hope you understood the module clearly. Thank you.